This is Alvaro Carrasco, and I will be giving a quick introduction to using actors in Unison. So, actors are a very nice primitive for building concurrent systems. But what is an actor? It's a running computation that can communicate with other actors by sending them messages. To get a sense of what they are and get a sense for them, we'll dive right in and start making some. We'll start with a main function, so we can run this as a regular program. And we'll create our first actor by using actor.run, which takes the name of the actor. We'll call it root. And as a second parameter, it takes the behavior of the actor. It's just a function where we can just start by logging that this actor is running. When we run this, it appears that nothing has happened. That's because this main function is exiting before this actor has had a chance to run. Each actor gets run on its own thread that runs parallel to whatever thread spawned it. So for now, what we'll do is we'll instruct the main function to sleep for a little bit. We'll have it sleep for 5 seconds, just to give this actor a chance to execute. When we run it again, you can see that the actor is able to log that it is running. One thing an actor can do is suspend its behavior for a certain amount of time. To do that, we'll use wait seconds and tell it to wait for 2 seconds, after which we'll log that it is done waiting. So this time, if we run it, you can see it logged that it was running, and then 2 seconds later, it logged that it's done waiting. Okay, a single actor is not very interesting, so we'll create another actor, but this time from within the behavior of this actor. To do that, we use the spawn function, which also takes the name of this actor, of this new actor, which we'll call child, and a function that defines its behavior. And we'll keep the behavior very simple as well. We'll just log that this new child actor is running. We'll run this again. And you can see that after the root actor started running, it waited for 2 seconds. Then the child actor was spawned. It logged that it's running. And then our main function exited after the 5 seconds. Okay, next we will send this child actor a message, which is how you communicate with any running actor. It's the only way to communicate with an actor, by sending messages. And to do that, we use the send function. And since we're in the context of the root actor's behavior, we'll just say hi from root. When we run this, it appears that nothing happens. That's because sending an actor a message only places this message on the receiver actor's mailbox. The receiver of the message has to still explicitly receive the message to dequeue it from its mailbox. To do that, we use the receive function. So after we receive the message, we will log that it received that. Okay, this time when we run our program, we can see that the child actor logged that it received the message from the root actor. Okay, what happens if we send another message? Okay, we see that it received the first one, but it didn't receive the second one. That's because the way receive works is it only receives one message if there's one available. If there isn't any messages available, it suspends the behavior of the actor until a message is sent to the mailbox of this actor. But it only receives one message. If we want to receive more than one, we have to call receive again. So we'll log again, but this time that we've received a second message. Okay, now you can see that it's received the first message and then the second message. You can also receive more than one message like this by calling receive twice as part of a list. Let's call this 2 messages. And we'll log that it received the 2 messages. And this is just a function to turn this list into text. Okay, here you can see it received both of those messages. Okay, next, an important part of an actor is its ability to maintain state. And the way we can do that is by defining the state as a parameter to its behavior. So instead of doing this here, what we'll do is we'll create a new function that defines the behavior of this actor. We'll call it behavior, which will take as a parameter the total number of messages received, because we want this child to remember how many messages it has received so far. So this defines the behavior, but in order to get it started, we need to use this as part of our the definition of the top level behavior. So we'll tell it that the initial behavior of this actor will be that it has received 0 messages. Then we'll log how many it has received so far. And then we'll attempt to receive a message. Okay, then we'll log that we've received this one message. And next, we will tell it how to continue after receiving this message. And we want it to continue using the same behavior, just with an incremented total. And that's how an actor is able to maintain state, essentially by changing its behavior in a way where it has access to some state that has been modified as part of the previous behavior. So if I run this now, you can see that it logged that its initial state was a total of 0 messages. It received 1 message from root. Then it continued on with this new behavior with the incremented total, which it logged right here. Then as part of its new behavior, it received a second message, and then it logged its new behavior again with an incremented total. Okay, that concludes this very brief introduction to actors in Unison. On the next video, we'll work on making some fun simulations with actors. See you then.